We're now going to take a look at a couple of financial functions. I mean, the whole purpose of going over this stuff is to help with the business environment. So it'd be good to kind of know at least a couple of functions that are related to finances. And the first one we're going to take a look at is what's called the payment function, or PMT. So there are three arguments in here: the rate, the number of periods, and the amount. And what this function is going to do is we're going to return the periodic payment based on some interest rate over a period. And it's also going to be based on the total number of periods and the total amount to pay. So what we're saying here is, let's say you buy something and there's an interest rate involved, and you know how many payments you're going to make in the total cost. So you can figure out what's going to be your periodic payment. So like, for example, let's say we want to calculate a monthly payment. So we would actually say we would divide the rate by 12. So we would take whatever interest rate is and divide it by 12, because there are 12 months in a year. And then we would set the number of periods in months. And it's also worth noting that the amount needs to be negative. If you make it a positive number, your result gets negative. Why they do this, I don't know, but the amount should be negative. So just to give you an example here, if we want to, let's say, buy something that's $25,000, maybe we're buying a car, and we're buying a car at a 3% interest, and we're going to make 75 payments. So notice that in the PMT function, we have 0.03, that's the 3% interest, and then we divide it by 12, and then we have 75 payment periods, and our amount is negative 25,000. This is going to return 366, which would be our monthly payment. So if we pay $366 per month for 75 months, we'll pay off this car. The last function we'll take a look at involves investment, and this is called the future value function, or called FV. This also has a rate, a number of periods, and a periodic payment. Now the periodic payment is a little different from the amount from the other function, but this is like how much money we're going to put into it. So what this function is doing is, let's say we're going to invest so much money per period, and there is a fixed interest rate over this period of time. So this would tell us how much money we would actually get if we do this investment. So if we invest based on the interest rate over a period, the total number of periods, and the payment of each period, we can actually figure out how much we have actually accumulated. And this is great, like, for example, if you want to save up for retirement, or if you're going to invest in something that has some type of return. Now, just like with the payment function, the periodic payment part has to be negative. So just to give an example here, let's say we invest $3,000 a year for 40 years, and let's assume that we have a 7% interest rate. Now, for modern days, that's a very, very generous interest rate. You're never going to get 7%, but let's just go with it for now. So if we apply those values into our function, this means that if we invest $3,000 a year for 40 years at 7% interest, we're going to get $598,905 back when you incorporate all that interest. So that may say a little something about maybe trying to save up some money for retirement now instead of waiting until you're like 30 or 40 years old.
Now that you have a better understanding of both the payment and the future value functions, let's try them out in Excel and see what happens. So let's say we'll do the payment function first. So let's say in this example we're going to buy a house. So let's put in some values in here. House, we'll do house price, we'll do interest rate, and we'll do number of payments. So then we can put in the, we'll do a monthly payment. Okay, so let's say that we buy a house, and we'll put it over here. Let's say we buy a house for $120,000. And let's say the interest rate, let's see here. Let's say it's about 3.5%. And then number of payments, let's say we get a 30-year loan. So that means it's going to be 30 years times 12 months in a year. So we're going to get 360 payments. Okay? So with all that, we should be able to compute a monthly payment. So let's do equals PMT. Okay, so the rate is here. Here's our rate, 3.5%. Then the number of payments, 360. and then the payment value is right here. And remember, we're going to make this negative. And then we're not going to worry about the other arguments in here. So if I hit enter, that seems a little on the high side. I think this needs to be divided by 12, if I remember right, since it's monthly. Yeah, we need to make the, there we go. Yeah, I think we remember mentioning that if we do a monthly payment, we need to divide that by 12. Okay, that looks a lot better. A monthly payment of $4,000 is a little high for a house. Yeah, here we go. Yeah, so we take the yearly interest rate divided by 12, and that gives us what we need. Yeah, so here we see that if we get a loan for $120,000 to buy a house, the yearly interest rate is 3.5%, and we pay every month for 30 years, the house payment, or the monthly payment for the house, would be $538.85. So you can use this, just kind of give you an idea of how much you're going to have to pay for something. If you know you're going to take out a loan, you have an interest rate, and how many payments you're going to have to pay back, you can kind of get an idea of what your monthly payment is going to be. All right, so that's the payment function. So I'll just put it up here, payment. So let's try out future value. So we'll put it over here. So remember here, this is the idea where we would maybe put money into something and then let it grow for a bit and see how much we would get. So let's say, let's try monthly investment, interest rate, and then number of payments, and then our total. Okay, so let's say we put $5,000 a year into something. That's weird. Let me change that. I think it was from an earlier example. There we go, $5,000. There we go. And then our interest rate, well, let's face it, interest rates nowadays isn't pretty good. So let's just do like, we'll do 2%. That's pretty generous here. And then let's say we do this every year for 40 years. So what's going to be our total? Well, we'll do equals FV for future value. So our rate is 2%. And this is yearly now, so I don't have to divide by 12. If I was doing something every month, I have to divide it by 12. But here it's per year. Here's my number of payments. And then my payment is right here. For some reason, I still have to make it negative. Otherwise, it's going to look like it's negative. So what we would get here is if we... I don't know why I said monthly investment. Technically, this should be yearly. That makes a little bit more sense. So if we invest into some type of accounts $5,000 every year at 2% interest, and we're assuming that that 2% stays for the entire 40 years. And if we do this for 40 years, we would see that the total amount of money that we would get is $302,009.92. Now, I'm just going to try something here because I'm curious now. How much do we get in interest? Oh, well, the way we can do that is I'll just put it down here. Is if we do $5,000 a year times 40 years, we would see that this would be $200,000. So what this is showing you right here is you would get $102,009.92 in just interest if you were to do this, instead of just saving that $5,000 in like a savings account or something. So this just kind of gives you an idea of how much you could potentially get with interest.